So, let's go. Number 1. The methane that appears and vanishes. Here's the thing about methane. On Earth, most of it comes from something alive. Cows, swamps, bacteria in the dark. So when a robot the size of a car starts smelling it on Mars, people pay attention. Curiosity has been parked in a crater called Gale for years, and every so often it takes a deep breath of the air around it. And it keeps finding methane, a little in the background that rises and falls with the seasons, and then, out of nowhere, a spike. One reading was the biggest yet, dozens of times higher than the quiet baseline. So here's where it gets strange. There is a spacecraft in orbit built specifically to hunt for exactly this gas. It is the most sensitive methane detector ever flown to another planet. It passed over the same spot within days of the rover's readings, and it found almost nothing. Barely a trace. Think about what that means. One machine on the ground says the gas is there. Another machine overhead looking right at it says it isn't. Both of them work. Both of them are careful, and they disagree about whether something is in the air. The best guess is that the methane leaks out at night when the air is cold and still and hugs the ground where the rover can taste it. Then the sun comes up, the air stirs, and it's gone before it can climb high enough for the orbiter to see, which is a clever answer. But it doesn't tell you the part you actually want to know. Where is it coming from? It could be water quietly reacting with rock deep underground, making gas the boring way. Or it could be something else. Nobody can rule the something else out. And that is the problem with Mars. You never quite get to close the door. Number 2. The oxygen that breathes on its own. While everyone was arguing about the methane, the same rover handed scientists a second mystery that is somehow worse. For 3 Martian years, Curiosity measured what was in the air above that crater, and it watched the oxygen do something it is not supposed to do. Every spring and summer, the amount of oxygen climbed. As much as 30% above what the math allowed. Then, come winter, it sank back down to where it belonged. And the next year, it did it again. Now, gases on Mars are supposed to be predictable. You know how much carbon dioxide is there. You know it barely changes. And the oxygen should just tag along quietly. Instead, the oxygen was rising and falling like something breathing. So the scientists did the responsible thing. They tried to explain it away. Maybe sunlight was cracking water molecules apart, but you would need 5 times more water in that sky than actually exists. Maybe the carbon dioxide was breaking down. But that happens far too slowly to make the spikes they saw. One by one, the ordinary answers failed. And here's the detail that keeps people up. In some seasons, the oxygen and the methane seemed to rise and fall together. The scientists were very careful not to say the word everyone was thinking. They just wrote down what they saw and admitted they could not explain it, which, coming from NASA, is its own kind of unsettling. Number 3. The streaks that flow downhill. Look at the right Martian hillside at the right time of year, and you will see dark streaks running down it. They are thin, like someone dragged their fingers through the dust. And they move. In the warm season, they grow longer, reaching down the slope. When it gets cold, they fade. Next year, they come back in the same places. When these were first spotted from orbit back in 2011, the excitement was immediate. Streaks that appear when it's warm and vanish when it's cold sound exactly like water. Flowing, seasonal, liquid water on Mars right now. And then the fight started. And it has not stopped since. Because when you measure the slopes those streaks stop on, they match the angle where dry sand naturally stops sliding, not water. Just dust and grit avalanching down in slow motion. One group of scientists says it's granular flow, plain and dry. Another group, with newer data, says no, there really is briny water melting out of the rock underground. 10 years of the smartest people in the field, and they still cannot agree on whether those streaks are wet. And this one actually matters for a very practical reason. If there is liquid water in those streaks, we are not allowed to drive a dirty rover through them. Earth bacteria hitchhiking on our hardware could contaminate the one thing we came all this way to look for. So a few dark smudges on a hillside are quietly deciding where humanity is even permitted to go. Number 4. The Medusae Fossae formation. Now zoom out, way out, because the next anomaly is not a wisp of gas or a smear on a slope. It's the size of a country. Straddling the Martian equator, there is a deposit of soft, crumbly rock so enormous it covers around 2 million square kilometers. That is about a fifth of the continental United States. It has been carved by the wind into these strange flowing ridges like frozen waves stretching past the horizon. And for a long time, nobody knew what it was or where it came from. Was it ash? Was it dust piled up over eons? Was it hiding ice? The stuff is so light and so easy to see through with radar that even figuring out what it was made of was a struggle. The leading answer now is volcanic ash, which sounds tame until you do the arithmetic. To pile up that much ash, ancient Mars would have needed explosive eruptions on a scale that dwarfs anything in Earth's history. By mass, this single deposit is something like 100 times bigger than the largest explosive volcanic deposit our whole planet has ever produced. And if that's true, those eruptions would have belched enough gas to change the entire Martian climate. A buried record of a violent chapter the planet went through billions of years ago, sitting right there in the open, and we only recently started to read it. Number 5, the manganese that shouldn't exist. The rover zapped a rock. It does this a lot, firing a laser to read what things are made of, and in the middle of ordinary Martian sandstone, it found something that made a few scientists go quiet. Manganese. Specifically, manganese oxides, the dark metallic stuff. And on Earth, there is really only one way to make it in any quantity. You need oxygen in the air, or you need living microbes, and either way, you need a lot of water and strongly oxidizing conditions. As one scientist put it, the only ways we know how to make these materials involve atmospheric oxygen or life itself. And here it was, in high concentration, on a planet we were told never had much oxygen at all. So take your pick, and neither option is small. Either early Mars had far more oxygen in its air than anyone believed, which means it was much more like young Earth than we thought. Or there is some exotic chemistry out here, involving other elements that cooks up manganese without any oxygen at all, which means the rules we use to read rocks don't fully apply on Mars. A single dark vein in a stone, and it forces you to choose between two conclusions that both rewrite the story of the planet. Number 6, the storms nobody can predict. Most of the time, Martian dust storms are local, a patch of weather kicking up grit, nothing dramatic, but every few years, one of them doesn't stop. It grows and swallows the entire planet. In 2018, one of these started as a normal storm. Within about 2 weeks, it had spread across a quarter of the planet. Then it kept going until there was no planet left to cover. The whole world vanished under a shroud of dust. The sun from the surface became nothing, and somewhere under that dust was a small rover named Opportunity. It ran on sunlight. It had already been working for 15 years, far longer than anyone dreamed, and as the sky went dark, its power drained away. Its last message came through, and then silence. Months later, it was declared lost. A dust storm reached across a planet and switched off one of the most successful machines we ever built. Here's the part that should bother you. We still cannot predict these. We know they tend to happen when Mars is closest to the sun. But which years explode into a global monster and which stay quiet, nobody can reliably say. The gaps between the big ones stretch out for years for reasons no model captures. And that same dust is fine and toxic and charged with static. Whatever crew we eventually send will be landing inside this uncertainty, hoping the planet doesn't decide to pull its shroud over them. Number 7, the spirals at the pole. Fly over the North Pole of Mars and look straight down, and you will see something that looks wrong. The ice cap is white, and cut into it are enormous dark troughs, spiraling inward, curving around the pole like a fingerprint or a galaxy. One massive canyon slices across the whole thing. It looks carved. It looks deliberate. It looks, honestly, a little bit designed. The ice here is stacked in layers, dust and frost pressed down over ages, going down about 2 kilometers deep. And those spirals are the feature that makes people squint and ask if something made them. Something did. Just not anything with intent. This is one mystery we actually mostly cracked, and it's worth being honest about that. The wind blows off the high center of the cap toward the edges, and the same force that makes hurricanes twist on Earth bends that wind into a spiral. The sun eats at one side of every little dip in the ice more than the other. Over roughly 2 million years, that slow, patient carving turned a smooth dome into this hypnotic swirl. So no, nobody built it. But stand back and look at it, and you understand exactly why the first reaction is that somebody must have. Number 8. The dunes that shouldn't move. The air on Mars is thin. Painfully thin. About 1% as thick as what you're breathing right now. The winds, when they come, are weaker and rarer than ours. By every reasonable calculation, there simply is not enough force in that ghost of an atmosphere to push heavy sand around. And yet the sand moves. From orbit, cameras have watched entire dunes, some of them 60 meters tall, creep across the Martian surface as single, coherent shapes. Ripples shift. Whole fields of sand walk downwind on a scale that, over time, rivals deserts on Earth. On a planet where the wind is barely a whisper. How? The best answer is that the very thinness that should stop the sand is what saves it. In that feeble air and lower gravity, once a grain is finally kicked loose, it flies farther and faster than it ever could on Earth before it lands and knocks the next grain free. And once the ripples are rolling, it takes almost nothing to keep them going, a tenth of the wind that started them. The result is dunes that move in ways they simply do not on our world, bedforms with no match on Earth. The planet took a rule we were sure of and quietly bent it right in front of the cameras. Number 9. The grooves on Phobos. Leave the surface now, look up. Mars has 2 little moons, and the closer one, Phobos, is covered in something nobody can fully explain. Grooves. Long, straight, parallel lines. Scored across the moon's whole surface like claw marks, like something raked it. We have known about them since the 1970s, when our first probes flew past. And for around 40 years, planetary scientists have been arguing about what put them there. One idea says they are chains of tiny craters punched out when debris blasted off the surface of Mars swept across the moon's path. Another says Mars is slowly tearing the moon apart with its gravity, cracking its surface into fractures. That one has a problem, though. A lot of the grooves point the wrong way for stress cracks. And a third idea says that when a giant crater was blasted into one end of Phobos, huge boulders rolled and bounced across the surface, carving the tracks as they went. The frustrating truth is that no single explanation covers all of them. Some grooves fit one theory, some fit another. It's a small moon, barely worth calling a moon, and it has kept its scars a secret for half a century. Number 10. Where the moons came from. And while we're up here staring at Phobos, there's a bigger question hiding behind it. We don't actually know where either of Mars's moons came from. There are 2 stories, and they can't both be right. The first says the moons are captured asteroids. They wandered in from elsewhere, got snagged by Mars's gravity, and never left. And when you look at what they're made of, they do look a lot like certain dark asteroids. That fits. Except for one thing. Captured objects should end up in messy, tilted, stretched-out orbits. And these 2 moons circle Mars in neat, nearly perfect rings right around its equator. That is not how you'd expect captured strays to behave. So the second story says something huge slammed into Mars long ago, blasted a ring of debris into orbit, and the moons formed out of that wreckage, the way ours may have. That explains the tidy orbits beautifully. But nobody can pin down the size of that collision or the disk it left behind, and the numbers keep fighting each other. 2 moons right next door, and we cannot say whether they were born here or adopted. There's a mission on the way built to grab a piece of Phobos and bring it home, specifically to settle this. Until then, they just hang there, keeping quiet. Number 11. The blueberries. Back down to the ground for this one because it's smaller and stranger than all of it. Years ago, a rover named Opportunity rolled onto a Martian plain and found it littered with tiny spheres. Millions of them. Little gray balls 2 to 5 millimeters across, nearly perfectly round, half buried in the dirt, and scattered everywhere you looked. The team nicknamed them blueberries. The comfortable explanation is that they're concretions. Water soaked through the rock long ago, minerals gathered into little balls, and as the softer rock eroded away, the hard spheres were left behind. We have the exact same thing on Earth. It's a tidy, watery, believable story. Except for one detail that refuses to sit still. Every single blueberry ever found on Mars is small. None of them get past about 6 millimeters across. And on Earth, concretions have no such limit. They come in all sizes. So why did the Martian ones stop? As if something capped them. That size limit has cracked the door open for a stranger idea, that some of these aren't concretions at all, but tiny beads of molten rock flung out and frozen in flight, maybe from ancient impacts. Millions of little spheres, and we still argue about whether water made them or the sky did. Number 12. The Viking result that never died. This is the oldest one, and it is the one that never lets go. In 1976, 2 landers touched down on opposite sides of Mars. Each carried an experiment with a simple, bold idea: scoop up some Martian soil, feed it a broth of nutrients laced with radioactive carbon. If anything alive is in that dirt, it will eat the food and breathe out the tagged carbon, and the machine will hear it. They ran it, and the machine heard it, a clear positive. Then they did it again, on both landers, thousands of miles apart. 4 times it came back positive. And when they cooked a sample first to sterilize it, the signal went away, exactly like it should if something living had just been killed. By the textbook, that is what a positive life detection looks like. Here's the turn, and it's an honest one. A different instrument on those same landers searched the soil for the building blocks of life, the organic molecules, and found nothing. And you cannot easily have living things and no organic material at all. So most scientists concluded the soil chemistry itself, some aggressive reactive compound, had faked the signal. That is a reasonable explanation, and it is probably right. But it was never proven, and it never fully closed the case. The man who ran that experiment argued until the day he died decades later that in 1976 we found life on Mars and then spent 50 years talking ourselves out of it. Right now, another rover is filling little sealed tubes with Martian rock, samples that might finally hold the real answer, and setting them down on the surface. They are waiting there for a ride back to Earth that keeps slipping further away. So maybe the most concerning Mars anomaly isn't a gas, or a streak, or a scar on a moon. Maybe it's that the answer is already sitting in the dirt, sealed and labeled, and we just can't reach it yet.